A couple of things first before we go into multiplying these completely. Just some things for multiplying mixed radicals. What happens when you have something like a 4 root 2 and you multiply that by 3 root 6? What you're always going to do is you're going to multiply the numbers in front and then multiply the radicals. I'll call the numbers in front the coefficients, so multiply the coefficients and multiply the radicals. This is important. So if you have something like a 4 root 2 times a 3 root 6, well, multiplying the coefficients, 4 times 3 will be 12, and multiplying the radicals, root 2 times root 6 will be root 12. Then, after you've multiplied the coefficients and multiplied the radicals, you're going to have to simplify if possible. And so looking at this one, can we break up 12 with one of the numbers being a perfect square? Yes, it's 4 times 3. 12 is 4 times 3. Now, the square root of 4 is 2, so when I bring it out, I'm going to bring out a 2. It's going to hit that 12, and that's going to give me 24, and I still am left with a root 3 inside. So this is the basics for multiplying mixed radicals. And that's going to come up a fair bit when we expand these completely. So we'll go to our first example here. We have a binomial multiplied by another binomial. And so we're going to FOIL. We're going to multiply the first ones. We're going to multiply the outside ones. We're going to multiply the inside ones. And we're going to multiply by the last ones. And then we're going to use those ideas of multiplying mixed radicals throughout this. So when I go to my first ones, I have a mixed radical times a mixed radical. I multiply the coefficients. 4 times 3 is 12. Root 2 times root 2 will be root 4. We'll simplify this after. We'll just go through multiplying all of them first. When I look at my outside ones, 4 root 2 times a negative root 5. There's no number written out in front of the root 5, but you can imagine a 1 there. So when I multiply 4 times a negative 1, I'll get negative 4. Root 2 times root 5 will be root 10. Looking at my inside ones, coefficients, 2 times 3 will be 6. Root 5 times root 2 will be root 10. And finally, in my last ones, a 2 times a negative 1 will be negative 2. A root 5 times a root 5 will be root 25. Now we have to look, can we simplify any of the radicals? Can I simplify the square root of 4? Yeah. Yes, it's 2, and 2 times 12 would be 24. I can't simplify 4 root 10 because there's no perfect square that divides 10. I can't simplify it here either then. But here with negative 2, the square root of 25 is 5, so when that gets multiplied by the 2, 5 times 2 will be 10. So after first multiplying the radicals, we then simplify, and then once we've simplified, we're going to look at this and say, are there any like terms? Are there any like radicals? Is there anything we can put together? Well, 24 minus 10 is just 14. Negative 4 root 10s is a like radical with 6 root 10s. So negative 4 plus 6 will leave me with 2 root 10s. Circle that because that's my final answer. Looking at B. I can go back there, yep. So for b, again, we're going to multiply everything out. First, outside, inside, and last. When I look at my first ones, 4 times 4 will be 16. Root 2 times root 2 will be root 4. We'll simplify that later. Outside ones, 4 times a negative 2 will be negative 8. Root 2 times root 3 would be root 6. Inside ones, 2 times 4 would be positive 8. Root 3 times root 2 would be root 6. And the last ones, 2 times a negative 2 would be negative 4. Root 3 times root 3 will be root 9. I can simplify the square root of 4. It's 2. 2 times 16 is 32. Maybe you already see these two are like radicals and will cancel out, so you're going to save some time by not rewriting them. And the last one, minus 4, square root of 9 is 3, so when I multiply that together, I'll get minus 12. And 32 minus 12 is 20. Notice that all the radicals disappeared. This is because the way this question is set up is I'm going to call 4 root 2 a, and I'm going to call 2 root 3 b, so that I can write it as this question was a plus b, and in the second one it was a minus b. Do you remember that from multiplying last year? Right? What was that called? Because when you multiply it out, you get a squared minus b squared. Do you remember the name of that? Difference of squares. The answer, this a squared minus b squared, is called a difference of squares. And if you recognize that, every time you do the FOIL, the first, the outside, the inside, the last, the middle ones always cancel out. And it always becomes just the first one squared and the last one squared. And so we have a difference of squares.